So today I'm going to be speaking quite a lot about SQL and ORMs. And when I was preparing that talk, I kind of had to choose between speaking more about SQL features and my favorite ones and ORMs, and I chose SQL features. So I will only be speaking about the Django ORM. SQL alchemy also supports a lot of the things I'm going to be speaking about, and I encourage you to kind of keep that in mind. But I'm sorry, I don't have time to speak about everything. So just a little bit about me. Michael said basically everything, but so I work as a software engineer at Citus Data. So we do open source extension of PostgreSQL that transforms it into distributed databases. I kind of like PostgreSQL a lot, as my job can show in this talk as well. And you can follow me on Twitter. I have a blog. I write a lot of articles on PostgreSQL and optimization and performances if you're interested in that. So why this talk? So the main reason I decided to give this talk is that I really often go to conferences, PostgreSQL conferences. I also speak there sometimes, and I really like the all SQL talks. It's fun, you learn a bunch of new features that you didn't think you could use in PostgreSQL. And but really often I would go back to my job and realize that I didn't really know how to actually include them in my applications. And also when you work with other developers, they want to maybe use more ORMs than raw SQL. So it's more like, how do I take these features and actually put them in the code is what I wanted to answer with this code. So this is like the official and serious reason. The less serious reason is that I was hanging out with my friends and we were listening to our favorite teenage bands, music things. And we started joking around about analyzing the content of the lyrics of the songs and how they evolved since we were teenagers to now. And that's why I'm giving this talk, is to write funny queries about very good artists. So we're going to speak about a few things. First, I'll just give you a basic reminder of what a SQL query kind of looks like. Then we'll go over aggregation functions, group bys, exists, subquery, and then funny things that maybe you haven't used yet, which is join lateral, window functions, grouping sets, and CT. So first, as I was saying, I have a very important data model. Basically, you can see that I have artists. They have an idea and a name. Then they have albums that they composed with, the name, the popularity, and the year. The popularity, I took it from Spotify, who gives you a popularity between 0 and 100. And then they have, in each album, there are songs, and then there are words and lyrics that I filled by crawling a website that I crawled so much that I got my IP blacklisted, and then all of my friends' IP blacklisted. Invite me to your place, it's great. I'm very nice. So what is in this database? There are 10 artists. There's one French person, so maybe you know Kyo. No? Aww. Then it's, Blink, Maroon 5, the Jonas Brothers. In the end, it's Britney Spears, Justin Timberlake, and I had fun. All of them, wrote 72 albums. There's 1,000 songs and words. So I used the structure that in PostgreSQL you can use for full text search. I won't be speaking about it too much today because there's not much time, but I just want to tell you about TS vectors. So the idea is that you have a sentence and you give it the language and you transform it into, with the function toTS vector. And it will break down to what we call axioms. So it's basically the base of the word. And so words like if you use love, loves, loved, different versions of the same word will be considered as the same base of the word. So it allows me to have a better analysis of the words that are actually used by an artist. So in Django, you can use it with search vector that will, in an annotation, put you a field with the vector. And there are pretty cool full text search supported by Django if you're interested in that. So, as I was saying, basic SQL looks like this. You do select columns from something, And sometimes you join with other tables, you filter, you sometimes order by, you limit. It's very simple in the end. What it would be in Django is that, a lot of what we do is get something with a primary key that would be transformed in a where clause on the primary key field. If you do filters, GT, for example, it would be, year greater than the value that you're filtering, and then you can do order by. So all of this is like obvious. It is pretty obvious what it does. Like when it's changing into the SQL query, it's very easy to guess what it's doing. Then yes, you can, as I was saying, there are also joins that you make with Django with select related. And what is my last example? Oh yes, sorry. The limit and offset we use them a lot for pagination. That's the moment where it's starting to be a little bit less obvious what it's going to do in SQL. But when you retrieve the query set and takes a subset of the list that you would have, it's actually transforming it into offset limit. So to start, as I was saying, very good example, we're going to look into the average popularity of Maroon 5's albums according to Spotify. To do that, we are going to use aggregate function, that is average in SQL. Here, it's very obvious how it is transformed into Django. We are going to use an aggregation, and we use the average function, and we give it the column. It's going to give you, as a result, one, value. In this case, it's a dictionary with the name of the aggregate that you want and the value. In SQL, it would just return you one row with one column. So continuing on aggregation functions, what we want now is what are the most words used by Justin Timberlake in his entire discography. What we want is the word, then the number of occurrences and the number of songs it appears to in. So for example, here he uses like love a lot. It's the most greatest artist for love using in my database. It's I don't know if you're interested in knowing that, but he used it in only 56 songs, though he used no less, but in more songs. So I don't know what that says, but here is what we want. To do that, so we are going to use the function count, the aggregation function. So first, what an aggregation function with count would do is if you do a simple count ID from the word table with a filter on artist ID, it would give you a single count, that is the number of words overall. And the second thing that I want, it's not actually what I want in this query. So I'm just showing you what count does. Then what you would want is the value, and for each value, for each individual value, how many times it appears. To do that, what you're going to say is you're going to select the value, you're going to give it a count, and then you're going to say group by value. So for each value, you're going to have a count. So that gives you that. The last thing that I want is also the number of songs it appears in. And in this case, so I want the count of individual song ID. And so for that, I'm going to add a distinct, so a second count with the distinct on song ID, and it will give me the number of songs the word appears in. Django supports that. Again, it's pretty easy to achieve it, so I encourage you to doing so. When you're going to do that, you're going to use annotate. So it means that for each row return, it will have like an extra field with the value that you want. So you're going to give it a count. And here you can do a count with a distinct equal true, and that will do a count distinct. The other thing that we want is the group by. For that, you're going to use values and the column, or columns if you're grouping by several columns. And values plus the counts will actually transform into, a count group by. So that's how we do that. To go further in aggregation functions, so we saw average and count in count distincts. There's also min, max, and sum. It's pretty obvious what they do, and they're all supported by the ORM. So now, Avril Lavigne composed a few songs. One of them is Complicated, and I want to know what words she only used in that song. Like in no other song, she used those words. Here's the list that I want as the result of my query. So what I'm going to use is something called exists. In this case, it's not exist because I'm doing the opposite of something that exists because I don't want the words that are in any of the songs. So I'm filtering the words with the song ID 342. This is complicated in my database. No, is it that? Oh, whatever. I'm doing a subquery where for each of the words that I'm going to have, I want to make sure that this word is not used in any other song. So for that, I do a filter on, I want the same artist, it's Avril Lavigne still. I want to make sure that it's not on any other song, so I'm filtering the words that are in other songs with the same value, and I'm doing a not exist. And so this is going to filter out all the words that actually have the same value in any other song. So to do that in Django, what I'm going to do is a subquery here. So I've defined the word with a filter with something called outerref, which allows me to reference the main query from the subquery. I exclude the ones that are in the same song. And when I do my main query, I'm going to use the exist on my subquery. The dash exist means not exist in Django. I annotate that with the value is unique, and then I filter the is unique is true. So what it's going to do with Django is that it's going to generate a query slightly different from what I showed, because as it's an annotation, it's actually going to add a column in my row. So you can see that the subquery is actually here twice, one in the columns and one in the filter. So I wanted to quickly also say that, so exist is good for this kind of examples, but there are things that we do with Django that we could do with exist that work pretty well. One thing is, for example, I'm filtering all the songs for which I have no words. For example, I didn't download the lyrics because I got blacklisted. So for example, in this one, what I would do is words underscore underscore is null, words being my related field. And it's going to do a left outer join and filter on the one that have no ID. Here it takes between 17 and 25 milliseconds to do that. If I do it with exists, it would take about 4 milliseconds, 4 to 6, so 5. So good at math, I know. So it's good to know that sometimes there are things that you can try with the ORM that would perform better. Now, the second thing that I wanted to do is, okay, now I want to know what words appear in the chorus. Because like if a word appears like 25 times in a song, but it's mostly in the chorus, then obviously it doesn't count so much as a very important word in the song. Or, I mean, it depends, but I was thinking that. So, for example, here what I want is the number of iteration of a group of words. To simplify it, I took 2 words. So I want the word and its next word, and how many times it appears. So for this chorus, I filtered all the words that are less than 3 words, 3 letters, sorry, to make it easier, or not, but make it more interesting, I guess. So here the turn light appears 4 times, light carry 4, carry home 4. So this chorus kind of is, it makes me know what the chorus is going to be like and how many times it appears. So to do that, what I did is, so there are 2 solutions for that. I'll show the first one because it's compatible with Django, and the second one is one of my favorite features in PostgreSQL. So the first version is a subquery. So what we're going to do is select the value of the word, and then we're going to select the next word. What is the next word? Well, select the value where the position is bigger than the one. I order by position, and then I just take the first one. So it's the first word that has a position higher than the one I'm looking at and it's the first one. So this is how I get my cars. To do that, again, I do a subquery that I limit with 1. And the other thing is, as I want to count for this, I add a count like this. You can still see the subquery, you can see the count. And now I do a group by the first column and the second column. Maybe you didn't know that, but with SQL you can do group by 1, 2, and it says like it's the first column and second column that you're selecting. It's just prettier. To do that in Django, so you define the subquery. And then you do an annotation with the next word is the subquery. And then the values allow me to do the group by. I have my count, and this actually gives me the same result I have with ProSQL. The second solution that I'm going to introduce is something called join lateral. Here in this example, it does exactly the same thing as a subquery. I would say that if you're curious about join lateral can do a lot of really, really cool things. And once you start to understand what it does, it becomes the thing that you thought, like you don't understand how you even lived without it. So here what I do is, so I do a join lateral with a subquery. And so it allows you to basically join with the main one. And here I select the second word dot value that is from my join lateral that I called second word. So it does exactly the same thing. There are moments where it's actually more interesting what join lateral can do. One example can be like, oh, you're looking for like a user and his last comment, and you want it in only one query. This is the kind of thing that join lateral can do. So now we're going to talk about the Backstreet Boys. Okay, so now what I want is for all of the albums of the Backstreet Boys, I want for each of them the ranking of all the words they ever used. So for the first album, the word that appears the most is roll, and then it's no, etc. So that's the first album. And for the second one, the rank starts again from 1. And is like, oh, the third word is love. And so for each album, I want a separate ranking of the words they used. For that, what I'm going to use is window function. So what I do here is that so first maybe I want to define what a window function is. So a window function is going to perform a calculation across a set of rows. In this case, the rows grouped by like partitioned by the album. And basically it's kind of this comparable to an aggregate functions, meaning like you can use the same thing, sums, counts, in this case rank. But the difference is that, like an aggregation function like average, for example, would give you one result, like one row in the end, like the average for all of the words or something. In this case, for each row, it's going to give you a separate value. So what I do here is that I want the rank for that, and I'm defining a partition by the album. And I order by the number, the count, because it's the frequency of the word in the album. So to do that in Django, you can actually use window functions. You will give it an expression that is the function that you're using. In this case, it's dance rank. And you give it the partition, in this case, album ID, and the ordering. The ordering is for ranks. For average, you don't need an ordering necessarily, for example. And then, again, I'm annotating my query set. And so I'm adding the ranking, and it's going to give me the result that I had here. So there's something with window function that is kind of a shame, is that you can't do this. For example, I can't filter out the value of my window function saying, hey, I don't want all of the words, I just want the words that are in the top 5, like the ranked 5 or less. So I can't do the where ranking is less than 5. It is because the filters are computed before the window function in Postgres. So it's not a Django thing. It's completely SQL thing that you can't do that. To do that with SQL, what you would do is basically put all of your function that is returning your window function into a subquery. So I would do select my columns from my subquery and filter out my subquery afterwards. And that's the only way to do that. This is not doable in Django. So what I do here is that I use the objects.raw and I put a fake ID because to be able to map a query to objects, I need a primary key column that I don't have because it's a weird query. So window functions that I was saying, they do calculation across a set of rows. You can use average, rank, and dense rank. There's a slight difference between the two, but honestly, who cares? Sum and count. So now I'm going to talk about one of my favorite features of SQL. This is like a very exciting one for me. It's grouping sets. Maybe you, who have used here grouping sets? Yay! So the person. Okay. So what it's going to do is that what I want from my result, the result of my query, is I want for each band the number of songs they have per album, per artist, per year for all of them, and the total. It's like I want that in the result of only one query. So what it would look like is here you can see for Maroon 5 in the first album they have like 13 songs and then 17. Overall they composed 76 songs, and Selena Gomez for each album composed that many. All albums I have 84 songs from her in my database. And for each artist, like in 92 I don't have many songs. I only have 8, 2019 is 43, and overall I have 1,012 songs in my database. This is the result of the query. So what I do here is that I use something called a grouping sets. And I select the name of the artist, the name of the album, the year of the album, and the count, so the number of songs. And then I give it different group bys. The first group by is artist name or album name, year, then it's artists, and then year. So what you can see in yellow is what is going to be in yellow in my result. The grouping by artist name will give me the total of rows for the total of songs for that, for an artist, etc. So this is a pretty cool feature. It's not available in Django yet. It's something that could be fun. I was thinking about doing an application to do this because it's fun. What I do is, in this case, you don't have any other choice than really just doing a raw SQL and doing a connection .cursor fetch all. What I do in this kind of case is that I like putting them in a dictionary because it's easier than to use because you have the name of the columns. To go further, so grouping sets, there's also cube and rollup. They are different, like it's also grouping sets, it's just different ways of writing them. So I put the equivalent if you're interested in that. And the last feature I'll talk about kind of fast because I think I'm running out of time, is a common table expression. Common table expressions are good when you have a big query that you kind of want to break down. They are comparable to subqueries, except they can do things like reference each other and things like this. But I will just show you an example on Justin Bieber's song. With this amazing query, what I take is in the first common table expression, I take the last album. In the second, I take all the songs that are not in the last album. And in my main query, I want all the words that only appear in the last album. And so I can reference my CTEs in my main query several times, and I can reference CTEs between them, which a subquery can't do. The result of this is that Justin Bieber allowed to say sorry, and that being a child is hard, and being an adult is disappointing. So The conclusion is that what I talked about today is, so aggregations, yes, they're compatible with the Django ORM, so our distinct group bys not exist and exists are. What is not is lateral join, a window function are, so you can use them, and I encourage you, like once you understand what window functions can do, it's pretty cool. And grouping sets and CTs are things that are really, really great, but unfortunately are not supported yet by the Django ORM. Thank you.